Now, if I shade like this to consider the area, first moment of area, which rule did we break? Anyone? Which rule did we break? There's some
4.
Number 4.
Yeah. We have broken broke rule number 4. Right? So this is wrong. Okay, this is not. What if now, okay, what if now maybe we will take this area? Okay, if that's not correct, so okay, so we look at this. Same thing. So if we were to obey rule number 4, right? So let's say, okay, Eugene say this is we cannot cross, right? So if Eugene say we cannot cross, so this is still our x, and this is still our point alpha, right? So Eugene say, hey, we cannot cross the centroid, right? So maybe we can do this area. Sorry, wrong color. I'm partial color blind, okay, so I can't tell. Okay, so I'll take this area. Eugene say cannot cross the. Is this right or wrong?
Wouldn't it still be wrong?
Why?
Because it's still on the other side of the centrum.
No, we have broken rule
4.
number 3.
3.
So rule number 3 said that the analysis will start from what?
The maximum distance relative to the centroid.
Right? We'll start from y max. Right? So if it's Vy, right? If it's Vy from the bottom, right? Vy. Right? And if this is alpha, right? Then I'll ask you, is taken this area correct?
Yes.
Yeah. So this is correct. Okay. So for this case, we obey rule number 1, 2, 3, and 4. Right? Okay. So this is critical. Okay. That's why these 4 rules are critical. Okay. So what I'm trying to tell you is this: do not look at the direction of Vy. Sorry, where Vy start from does not matter. Where Vy start from does not matter, right? Okay, this is mathematically. Okay, this has been derived mathematically. I did not want to spend too much time deriving it because I wanted to show how you have to apply. Okay, now remember what I told you. Where Vy starts from is so important. Now someone has trying to speak. I will not talk. If you have question, you can ask me.
I do have a question, and it's how would you derive that? Do you just take the negative or the reciprocal number of Vy?
No. For at this stage, I will not do not consider positive or negative yet until we do mole circle. Okay. Yep. Mole circle then is critical. For now, I don't want you to know that yet. Okay. Right.
Sir,
then yes.
So can you go over rule number 3, analysis to start from y max? I couldn't understand why rule
analysis start from y max means if this is 0, right? Y max is at the furthest distance. Yes or no?
Yes.
That is what it means. It starts from y max and then it comes in the analysis in this direction. Okay. If we were to choose this direction, right? This is our analysis direction and it's wrong. Right? That's why I say we broke rule number 3. Yes or no? Cyan.
Yes, yes, that
Yeah.
makes. Thank
Yeah.
you.
Okay. Now, what if now? Okay. What if now? I give you another example. Same thing. What if now I want to find the stress at beta? Which is the area we consider? Anyone?
Everything below beta.
Okay. So basically, you're absolutely right. It is this area you have to consider. Okay. Why? Because over here, the analysis direction, okay, it will start analysis from here. It will go over here. So this is the analysis direction. Right. The distance from here to here, this is your Y max. We obey the rules. And we did not cross over the what? We did not cross over the centroid, right? We did not intersect the centroid. Right. Now, this is critical, right? That's why this chapter, two key formulas, VQ over IT or VQ over I, first moment of area. All you need to do now is to apply the 4 rules. Okay. A lot of time mistake is made here. A lot of times. Calculating the first moment of area is confusing as hell. Okay, I will tell you that. Okay, but once you apply, I was also confused when I taught this the first time. Okay, I was so confused. Okay, until I sit down, solve a lot of questions, I came up with all these rules. Bob's your uncle. I want you to learn all these rules. Okay, apply all these rules. This chapter is easy. You don't apply all these rules, this chapter is as difficult as it comes. Are we clear? Okay, now I want to immediately go into an example. Okay, I want you all to see the example, how it works. Okay, more important. That's why I skip deriving the 4 rules, just show you the 4 rules, how to apply. Okay, so let's look at this problem now. Okay, example number 1. For the beam and load shown, okay, consider section NN. Okay, so consider section NN over here. Determine the shearing stress at point A. Okay, so we see point A is here. And determine the shearing stress at point B. Okay, so that is what we are asked to do. Okay, so this is a problem that has a lot of steps. Okay, and I'm going to show you all these steps. Okay, they are and you realize that now you tell me, Eugene, this is no more a rectangle. It has a weird shape. Yes, you're absolutely right. Okay, so what are the things that you will learn from this example? Okay, so you need to I want you to draw. The first thing we will do is draw the free body diagram. Okay, then we have to find, okay, from here we have to find the reactions at point A and B using static analysis. Okay, and then we are going to draw a shear force diagram. To determine V. Then after that, we are going into calculate our shearing stress, or calculate okay. So to calculate shearing stress, the formula is shear stress is equal to VQ over IT, right? So V we know already, okay? So the next thing we have to calculate, okay, which is subsidy of this, is we have to calculate the centroid position. Okay. Why we have to calculate the centroid position? Because we don't know, or I don't know, where the centroid is located. I have no clue. Okay. And I'll show you how to do it. Okay. Where is the centroid? I don't know. Okay. If it's rectangular, it's easy. It's top area, bottom area is the same. You just draw a straight line. Or left and right area is the same. You just draw a straight line. That's straightforward. And then the next thing, after we found our centroid, then we are going to calculate our second moment of area. Okay. Then we are going to find out how to calculate our calculate our first moment of area. And then finally, we find the shearing stress at point A and the shearing stress at point B. Okay. And if we have time, okay, I'm going to derive the shearing stress distribution equation. Okay, I'm going to derive the shearing stress distribution. Okay, so these are the points that we're going to do. Okay, as I said, it might take 1 hour to do everything, but let's do it. Okay. So this question is pretty unique in the sense that they told us to find the stress at NN, but they did not give us the distance x. Where is this x value? Okay, or is this x value important, right? So I'm going to specify our transformation first. Okay, so for this case, right, this is our x, this is our y, and this is rotation about z. The next view on the right hand side, you can see is our cross-sectional view, right? So if that's the case, a cross-sectional view, so this is our y, and this is our z, and this is rotation in the x direction. Okay, and then from here you know that, oh, now I can see that this is going to be your vy, right? This is your z axis now. So you know from this diagram, you know that you are going to find the shear stress in the xy direction is equal to vy over izz qz divided by thickness. Okay, and the thickness is dependent on the area of, or the region of interest. Okay, now coming back to here now. Okay, so we are going to, so where I mentioned we don't know where this x direction is. Okay, the next thing, if we don't know, is it important to know? Okay, so the best thing to do is you start your analysis first. Okay, that's the first thing I'll get worried. Okay, they give me NN, and they did not tell me that distance. Okay, so is that distance important or not? Okay, so for this case, later on I'll show you it seems not important. Other case.